we are now going to use factoring to solve formulas for specific variables. So suppose we have the formula 2g equals ch plus dh, and we want to solve for h. Well, it's important to recognize that we have an h in this term and an h in this term. So all my h's are on one side, but I can't narrow that down much farther. I can't combine like terms because c and d are variables, not numbers. But I can factor this side, which allows me to say 2g equals, we can pull an h out of it. That leaves behind c plus d. And now that the h is by itself factored, I can divide both sides by c plus d and get, as my answer, h equals 2g over c plus d as my answer. Now I'm solved for h. Well, that works fine if the variable you're solving for is on one side, but what if we have ar minus c squared d equals dm squared, where we're solving for d? So notice this time I have a d on the left and a d on the right. We want all of our d's on one side, and so let's move from this side over, because that's going to keep this one, make this one positive, keep this one positive, and it'll leave our term without the d alone. Otherwise, we'd have to move it too. So now ar equals dm squared plus c squared d. We recognize that there's a d in both of these, so we factor it out. Leaves behind an m squared plus a c squared. And now we do like we did on the earlier problem and divide both sides by m squared plus c squared, allowing that piece to divide out. And we get our answer of d equals ar over m squared plus c squared. So the key here, get the variable you're solving for all by itself on one side by first moving it to one side and everything else the other, factoring out the variable that you need, and then dividing over the remaining factor.